All right, guys, if you're one of my students, you know this is our first brand new lesson via YouTube. That means this is a lesson that I have not taught you yet. So I am looking for your input because I'm going to need to know, is it clear? Are you getting the information you need? Just make sure you drop me a comment. If it stinks, you can tell me to. You can email me that if you want to. I won't hold it against you, but in all seriousness, I need to know what helps you. So hydrates are a fun lesson. I hate we're not at school for this because I actually have a beaker full of copper 2 sulfate pentahydrate crystals. I always like showing my students. Next time I get into the high school, I might grab those and snap a picture of them so I can show them to you. So when you hear the word hydrate, I hope one of the first things that comes to your mind is maybe water. When we are hydrating, we're thinking about drinking water. Most people just hear that term and H2O comes to mind. So what a hydrate is it's a crystal, but it is an ionic compound which has incorporated water molecules within its actual crystal lattice, its structure. A lot of ionic compounds / salts like to do this. Now, before I get too far in, I want you to remember a couple things. When we hear the word salt, until you were a chemistry student, probably NaCl came to mind. Table salt, it's what we put on food. We sprinkle it on our French fries. It tastes good. But in reality, in chemistry, when we say the word salt, we could actually be referring to almost any ionic compound, because if it is an ionic compound, metal, nonmetal, perhaps a metal with a polyatomic ion, technically it's a salt. So when we say salt commonly around here again, although NaCl may come to mind, it could actually be any ionic compound. Calcium chloride, potassium bromide, potassium nitrate, all of those are types of salts. There are hundreds and hundreds of others out there. So why did I suddenly start talking to you about salt? Well, the reason is because hydrates are simply a salt or an ionic compound, which again have incorporated water molecules into the structure, the crystal lattice. Now, in your mind, you might be thinking, so is that like squishy? Is it going to be wet when I touch it? No, it looks literally like a solid crystal that you could just pick up, move around. Still has those pretty crystalline shapes that you might be familiar with. So what I'm going to teach you today are 3 things. I'm going to teach you basically what a hydrate is. We'll talk about that as we go through the lesson some more. I'm going to teach you how to name a hydrate, how to write the hydrate formula, and I am also going to teach you how to calculate the percent water in a hydrate crystal. Now, there are some other calculations you can do, and I may do some more in-depth videos on those later, but I am following the state of North Carolina standard course of study, and one of the things students are required to do in this course is to calculate the percent water in the hydrate. So that's the calculation that I'll be covering today. I did want to give you a little example here of what a hydrate is, just to give you a little picture on paper. So like copper 2 sulfate pentahydrate, if you could imagine for every copper sulfate molecule, and I'm just going to put a circle around it, if you could imagine this, for example, means there are 5 water molecules attached to each one of these. Now, this is obviously not a realistic drawing of what it looks like, but that just gives you an idea. And these are pretty loosely attached. You can actually take a hydrate and you can heat it, and the water is going to evaporate off, leaving you just with the salt. In this case, it would be copper sulfate, and I'll refer you to some videos later too online. There's some great stuff on this. You can Google hydrates and hydrate demos, and you can see some people heating these up. It's kind of neat because like the copper 2 sulfate pentahydrate, those crystals are just a deep, brilliant blue, just a beautiful blue color. But if you heat it up, like maybe crush it up, heat it over the Bunsen burner and evaporate all the water off, it then turns into a really light blue powder. So it's kind of like when you're doing laundry. When your clothes are dry, you know, they're this color, but when they're wet, you know how they always look darker? When you have copper 2 sulfate pentahydrate, those crystals are darker than when you've evaporated off all the water and just have the copper 2 sulfate. So just a little something to think about. That might put it in perspective for you. Now the next thing I want to talk about are what skills do you need to understand this lesson. And there are a couple things you do need to know in order to follow along easily. So I'm going to refer you to those videos in case you're like, wow, I probably need to go back and review something. You need to know how to calculate molar mass. That's one of the first videos I dropped into YouTube. You need to know how to write and name ionic compounds. There are 2 videos on that in YouTube. And you also need to know your numerical prefixes. I actually covered these in my lesson on writing and naming covalent compounds. But here they are again. I feel like most of you know these, mono, di, tri, all that. You've been exposed to these probably many times during your educational history and lots of different classes. Also, it is just flat out helpful to know that the molar mass of water is 18.02 grams per mole. That comes from the mass of 2 hydrogens added to the mass of 1 oxygen. If you know that little tidbit of information, that's going to make your math a little bit quicker today. And who doesn't like quick and easy? Work smarter, not harder, right? So these are the things that you need to know to move on. Now, the first thing that I'm going to start with you guys is just how to write and name a hydrate. This is so easy because you are going to be happy to know you already know most of this. So let's look at this first one. All you do is you look at the first part of the formula, and that's going to be an ionic compound. You already know how to do this. Now, this is ionic. Also, I want you to notice that copper is a transition metal, so we actually are going to have to use the stock method for this one. And what I see is copper is in a 1-to-1 ratio with sulfate. I know the charge of sulfate's -2, so this copper was a +2 because they would have canceled each other out. So this is called copper 2 sulfate. So we're going to write that down. Now, you see that fat dot? That's just showing you there are some water molecules that are loosely attached to this compound. That dot does not play a part in the name, but when you see that dot and then waters on the right side, that's how you know you have a hydrate. They're super easy to recognize. So to name the water part, what's on the right, all you do is you look at the number in front and you say its prefix. The prefix for 5 is penta. So you're going to write penta, and you follow that with hydrate. So really, this is the only new thing you're adding today to something that you already know. You name the ionic side, you say the prefix, add the word hydrate. So it's ionic compound, prefix hydrate. That's all you do. Really long name, really, really simple. Let's look at the next one. We have MgCl2, a fat dot, and 6H2O. So as soon as I see this fat dot and this 6H2O, I know I've got a hydrate. I know that the left side is simply an ionic compound. This is a binary ionic. It is magnesium chloride. And then we see we have the prefix 6. That is hexa. So we write hexahydrate. And that's all you do. If you would have seen this name 5 minutes ago, you might have thought, oh my gosh, that looks terrible. But again, once someone shows you the steps, it's really, really easy. And we're going to look at one more, and then we'll move on to the next step. So I see I have a hydrate. How do I know? I have this fat dot, and then I have some water molecules attached to it. So this is sodium carbonate. I have 10 waters, so that is decahydrate. That's it, guys. That's all you do. I've got you a little quick note here, just in case you want to pause and jot this down. So to name a hydrate, you write the name of the ionic compound first. Just follow your ionic rules. If it's got a transition metal in it, make sure you use the stock method like we did in that first example. Then you look at your prefix in front of the water. You write down that prefix followed by the word hydrate. Easy peasy. Easy, easy. And we'll go through and name some more in a second as we go through and do the next part. That's all you do. All right. Now let's move on and calculate the percent water in a hydrate. Now that you know how to name them, we're going to move right along here. So let me get out some different color markers. I hope my Sharpies don't run out during this pandemic. If they do, this teaching might stop. I'm going to have to order me some more of these on Amazon, I think. I'm really going through them. All right, so the first thing I'm going to do here is I'm going to go ahead and name it. And we already know this one. This is copper 2 sulfate pentahydrate. So there's our name. Now, I have a little process that I like to do with my students in class on this to calculate the percent water. It's just easy, and if you will do the same method I do, it'll look the same every time, and I think it's just really easy to remember. So here's how we do it. The first thing we always want to do is find the mass of the ionic compound. So you've already had the lesson on molar mass. If you have to write all this down as scratch work at the side, that's fine. I'm not going to do that today, but I'm going to walk you through it. So I've got 1 copper, and the mass of copper is 63.55, plus 1 sulfur, 32.07, plus 4 oxygens, which is going to be a total of 64. 16 times 4, 64. So that gives me a total mass of 159.62. So I'm going to write 159.62 grams per mole. All I did was I found the mass of that. Now we're going to find the mass of this. But if you'll remember, I said if you know the mass of water is 18.02, this will be quick. All you do is you say 18.02 times 5. So we're going to say 18.02 times 5, and that mass is 90.1 grams per mole. Now again, that 18.02 came from the fact that 2 hydrogens plus 1 oxygen is 18.02. If you know that, it's just super simple to multiply it by 5. You could have said 1.01 times 10 and then 16.0 times 5 and added it together, but if you'll just multiply this by 18.02, that saves you some time. So we found the mass of each side, and now what we're going to do is we're just going to add those two numbers together to get the total mass of the hydrate. So 90.1 plus 159.62 is 249.72 grams per mole. This is the total mass of the hydrate, because this entire thing is a hydrate. A lot of kids think the hydrate's just this part. The whole thing is actually considered a hydrate. Now what we want to do next is figure out what percent of this hydrate is water. You could experimentally find this if you actually had a sample of it, you took the mass, you evaporated all the water off, and then took the mass again. So you could hands-on very easily do this. The cool thing is you can also do it very easily on paper, which is what we're going to be doing today. So to get the percent water, you just write percent H2O equals, very important, keep everything labeled. You are going to put the total mass of the water, because that's what we're looking for. So this number right here is going to go on top. So 90.1 grams per mole over the mass of the total hydrate, which is 249.72. You're going to multiply that by 100, and that just gets it into a percentage. You could, some of you could do that in your head, but I want all the details here. So literally all you do is once you've set this up, you divide the mass of the water by the mass of the whole thing times 100, and you are done. We're just going to round to a whole number here. So 90.1 divided by 249.72 times 100 is approximately 36% water. So here's what you just found. Sometimes we get lost in the math and we forget, like, what was I even doing? Given this hydrate, if someone were to say, hey, what percent of that's, like, what percent of the mass came from just actual water molecules? We did the math, and we said 36% of this mass came from just the water. You actually could figure out the percent of anything in here. You know, I could say what percent came from copper, what percent came from oxygen. Whatever they're asking for goes on top, and then it's just divided by the total. You just want to make sure you're using the total mass of water. That's why we didn't put 18.02 on top, because we had to take into account there are 5 water molecules per every 1 copper 2 sulfate molecule. So let's do the next one. So let's name it first, because we know how, and that's pretty cool. So for this one, this is called calcium chloride. Dihydrate. So there's our name. And now we are ready to calculate the percent water, because that's what we're trying to find today. So the first thing I'm going to do is find the mass of calcium chloride. Chlorine has a mass of 35.45. I'm going to multiply that by 2, because there are 2 of those, plus 1 calcium, which is 40.08. And that gives me a total mass of 110.98 grams per mole. Now I'm going to find the mass of 2 waters. So I'm going to say 18.02 times 2, and that gives me 36.04. I should have known that off the top of my head. Grams per mole. Now to get the mass of the total hydrate, we will add these 2 numbers together. So 36.04 plus 110.98 equals 147.02. So I found the mass of the ionic compound, I found my total water, I added them together to get the total mass of the hydrate, and now we are ready to solve for the percent water. So percent H2O equals, we are going to divide the total amount of water by the total hydrate, what they're asking us for by the total. That's a good way to think of it. So 36.04 grams per mole divided by 147.02 grams per mole times 100. That just gets it into a percent for us. Let's plug that in and see what we get. So make sure you're putting these in the calculator with me. That way you actually know if you're getting them right. It's really easy just to watch and say, yeah, I've got that, but you truly never know until you've put it into the calculator. Also, you guys might need to check behind me because sometimes I make a mistake. So times 100, that's giving me about, I'm getting 24.51, so we're going to say it's about 25% water. Make sure you put the H2O there because we need to know what we were solving for, because we really could have solved for anything. And there you go. Now, I'm going to do 2 more examples just to make sure everybody's got it. And what you might want to do here is try these yourself and then unpause the video and see if you got them right. So let's put up the next example. Make sure I got everything straight here. If you guys could see my at-home setup, it's pretty interesting. I've got my iPad propped up on a big powdered sugar cardboard box held in place by a container of BBs from one of my boys' BB guns. So sometimes I can't see what I'm doing, so I got to take a peek up there. All right, now hopefully everybody's got that written down now. So I'm hoping you've done these. There were 2 of them. So let's go through and check them together. So this is a transition metal. So I'm going to have to use the stock method. That 2 came from up here. I know that because the understood 1 came from here. So that is cobalt 2 chloride. Hexahydrate. Cobalt 2 chloride hexahydrate. I'll just straighten this up. There we go. Now, let's do the math and calculate the percent water. So, chlorine is 35.45 times 2. And we're going to add to that 1 cobalt. The mass of cobalt, sorry, I'm trying to dig my periodic table out from under this pile of stuff. Okay, so cobalt got cut off on that copy. Let me look real quick. So right here is your mass of cobalt. Let me check something real quick here. Not sure why my periodic table had cut that off, but I did want to, I'm going to pull up another one here on my computer real quick. So we're looking at about, let's see. This is what happens when you film live, but that's okay. We're going to roll with it. 58.93. So I'm going to add that. So I'm getting a total mass of 129.83 grams per mole. And now we're going to get the total mass of water, 18.02 times 6. So that's giving me a total mass of 108.12 grams per mole. We are going to add these together to get the total mass. And my total mass is 237.95 grams per mole. Now we are ready to find the percent water. So we're going to say the percent water equals, remember, it is the total mass of the water, which is right here, over the total mass of the whole hydrate. So 108.12 grams per mole over 237.95 grams per mole times 100. Let's punch that in and see what we get. I'm getting about 45% water. And now for the very last one. Again, we have a transition metal in this ionic compound, so we are going to have to use our stock method, meaning our Roman numerals. When I look at this, I have 1 sulfate to 1 iron. Because it's a 1-to-1 ratio, and I know sulfate has a -2 charge, that has to be iron too, because remember, Mother Nature wants to balance those charges out. So this is iron 2 sulfate heptahydrate. Iron 2 sulfate heptahydrate. And now let's calculate the percent water in the hydrate. So I know that that if I have 4 oxygens, that's going to be a total of 64, 16 times 4, plus 32.07 for the mass of 1 sulfur, plus 55.85 for the mass of 1 iron. That gives me 151.92. And now we're going to figure out the mass of our water molecules. That is going to be 18.02 times 7. So that's a total mass of 126.14 grams per mole. Going to add these together. So 126.14 plus 151.92 equals 278.06 grams per mole. So we have the molar mass of our iron 2 sulfate, we have the molar mass of 7 water molecules, and we have the total mass when we've added them together. And now I'm just going to do this down here for the percent water. We say the total water divided by the total of the hydrate times 100. So 126.14 grams per mole divided by 278.06 grams per mole times 100 equals, I'm just going to imagine that my students are shouting out the answer because you've already found it, 278.06. Again, 45% water. And that, my friends, is how you name hydrates and how you calculate the percent water in a hydrate. Now, I've put together a little cheat sheet for you, just that kind of walks you through the steps. So I'm going to put that up real quick and let you have a look at it and just reiterate a couple things. So this is our hydrate cheat sheet example. So the first thing we did was I showed you how to name it. This is magnesium sulfate, no stock method here because magnesium is not a transition metal, heptahydrate. So I think the naming part's pretty easy. So here's how we find the percent water. The first thing we do is we find the mass of the salt. That's our ionic compound. That's just using our molar mass skills. Step 2, find the mass of the water. You multiply your prefix which is 7 in this case by 18.02. So you have the mass of the salt and the mass of the water molecules. Step 3, we add these two masses together to get the total mass of the hydrate. And lastly, to find the percent water, we divide the total mass of the water by the total mass of the hydrate. Remember, that's your total, times 100. That simply puts it into a percentage for you. Round to a whole number, 51% water. And I've got your little note here to explain what I did here. So I hope this was helpful. My students, I'm going to be looking for you to drop me a comment that you saw this. Do you understand it? Let me know what I can make more clear or if I can answer questions. And this is going to give me some real good information on how we're going to move forward in the course.